Welcome back to math, everybody. This week we're going to be going over the 11th of 12 units in your Math Legs textbook. This is Unit 11, Probability. Now, probability shouldn't be all that difficult for you guys because it is effectively a review of what you did in grade 7. But with that in mind, there'll be some concepts in the first lesson that we're going to review here from grade 7, and the ensuing two lessons, 11.2 and 11.3, will focus more on outcomes with multiple independent events. So, first we're going to look at the formula for representing probabilities, but prior to that, we kind of have to operationalize what probability means. Now, probability, what that means is chance. So what is the chance of something occurring is the same thing as saying what is a probability of something occurring. And there is a formula that we use for probability every time. Now that formula is total number of favorable outcomes versus the overall total outcomes. For instance, if we were to flip a coin right here, we have all our coins down here. If we were to flip that coin, the total outcomes on one coin, there are heads or there are tails. So therefore, there are two total outcomes on a coin. Now, the favorable outcomes, what are the odds of one of those outcomes occurring? If I were to ask you, what are the odds of flipping a heads? Well, heads in this case comes up favorably one time. So those are the favorable outcomes. So therefore, the probability of flipping a heads on a coin would be 1 in 2, or 50% if you're dealing percentages. Okay, likewise, if I were to ask you, if you were to flip a coin 7 times, now your total outcomes isn't 7 because in a coin, you flip it 7 times, and in each coin you can get heads or tails. So each flip, there are 2 outcomes. There are 7 flips, 2 outcomes in each flip. So therefore, if you were to flip a coin 7 times, there are 14 total outcomes. Okay, if I were to ask you this time, what are the probability in those 7 flips that you would flip a tails? Well, tails comes up 1 time in each of the 7 flips, so therefore 7 in 14 chance you would flip a tails. Okay, we're going to go on to the next slide now. Now we're looking at the different ways to show probabilities. Now, there are 2 real ways to show probabilities. Those are in a table and in a, well, we'll show you the table first, actually. So the first is the table. Now, with the table, on the side, you have, for heads and tails, you have the different outcomes you have and how many times you attempt the outcomes on the top. So this is what a table looks like. We know from basic probability that is if we do it 7 times, there's a 7 in 14 chance we would either flip a heads or a tails. Now, if you're going to show a chart to organize those outcomes, on your first flip, you could get heads. On your first flip, you could get tails. Second flip, heads. Oops. Second flip, heads. Second flip, tails. Third flip, heads. Third flip, tails, etc., all the way to the end. And as you fill in the chart, you will see all of the possible outcomes you could have. Sorry, let me just finish this chart for you guys because it's really important to show this. Oh boy. Let's use my mouse. That'll work. Okay, so here we go. We have a chart filled out, and in this chart, it shows all of our outcomes. Now, the one way to calculate it is with this chart. You look it up. These are all the outcomes. So in this chart, right now, there are a total of 14 outcomes. You can count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And how many times does heads come up? 1, 2, 3, 4, 5, 6, 7. So if I were to ask you, what is the probability of flipping a heads? You've counted the total outcomes in your chart, and you've counted the number of times heads come up in that chart. So therefore, it's a 7 in 14 chance. Now this here, when it shows all of the possible outcomes as it does in this chart, this is called a sample space. So when you've listed all of your outcomes, that is called a sample space. And the second way to show your probability is through something called, you guessed it right there, a tree. Now in that tree diagram, it's a little bit different. I personally enjoy the tree because it's a little bit quicker to organize. However, the downfall of a tree is it doesn't show a sample space, and you have to make a separate sample space for that. So right here, this is flip 1, flip 2, flip 3, flip 4, flip 5, and flip 6. On flip 1, you get heads or tails. Flip 2, heads or tails. Flip 3, heads or tails. Flip 4, heads or tails. Flip 5, heads or tails. And flip 6, heads or tails. Oops, heads or tails. And I forgot flip 7. Flip 7 here, you get heads or tails. Now, I've organized all of these things up, but is not necessarily organized in a sample space because it has to have all your outcomes there, so you'd have to go again right here if you're using the chart. Heads on flip 1, tails on flip 1. Heads on flip 2, tails on flip 2. Heads 3, tails 3. Heads 4, tails 4. Heads 5, tails 5. Heads 6, tails 6. Heads 7, and tails 7. I know this is really monotonous and it's over and over, but now, right here, we have our sample space right here. All of this is our sample space. Now we can count the same way as a table. You say there are how many total outcomes? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. There are a total of 14 different outcomes. And I say this time, what is the probability we hit tails? All you have to do is count up the number of times tails comes up, which is 7. Again, a 7 in 14 chance. Now, in this example here, we have multiple independent events occurring. In this case, those independent events are, let's use this color here. Those independent events are flipping a coin and spinning a spinner. So I'm going to ask you, what is the, let's use a tree diagram to calculate the probability of, let's say, flipping a tails and spinning a green. So what is the probability of flipping tails? So P, what is the probability of going tails green right there? Well, we have to calculate that in our sample space. So it's quite easy. So the coin, we can flip the coin. What are the total outcomes of the coin? There is a heads you could flip or a tails you could flip. Excellent. Now, if we flip a heads, what are the total outcomes in the spinner? Well, we do our tree. We could go blue if we flip a heads. We could go green. We could go white. And we could go red. Likewise, if we flip the tails, we could go blue, green, white, and red. Now, we have organized our outcomes. We can show what we can do with the heads right here and what we can do with the tails right here. The next step is, like with all tree diagrams, we have to create a sample space. So we go heads blue, heads green, heads red, heads white. Oops. Heads white. Or we go tails blue, tails green, tails heads, and tails white. And my question to you was this. It was, what is the probability of flipping a tails and hitting a green? Well, all you have to do now is go to your sample space and look up how many times does tails and green come up at the same time. So right here we've got, tails and green comes up 1 time. So the favorable outcomes are 1, and the total outcomes are 1, 2, 3, 4, 5, 6, 7, 8. So the probability of flipping a tails and then spinning a green are 1 in 8. Now, if we're actually to spin that spinner, let's see if we hit a green just for fun. I'm guessing blue. No, it was white. Wrong. Okay. So this is when there's 2 independent events. Those independent events are flipping a coin and spinning a spinner. They're independent because they have no effect on the other one, so they're just independent of each other. But likewise, if I were to ask you, for instance, what is the probability of us getting a tails in green, and I were to color this one in green right here, pretending there's no blue, the heads blue would be gone, it would be heads green. Tails blue would be gone, it would be tails green. Now, the odds of tails green happening, that happens twice. So in this case, there's a 2 in 8 chance. Okay, and moving on. And the same thing with the table. The only difference with the table is that sample space is pre-made, but you do have to make a table in that case. So if I'm going to fill in my sample space, on the top, I've got one independent event, which this is the spinner on top. So the sample space, or the top, indicates the spinner. I don't know why it keeps doing that. Let's try this again here. Oh, okay. Spinner. And on the side, it is the coin. The coin. So if I were to fill in that sample space now, I have this. I can go heads blue, heads white, heads red, heads green. Tails blue, tails white, tails red, and tails green. Now, we look at this. What is the probability, I ask, say, of flipping a... What is the probability of... Sort of go over here. Probability of going heads and red. Well, you look up the favorable outcomes. Heads and red comes up just one time. So that is one favorable event, and the total outcomes are 1, 2, 3, 4, 5, 6, 7, 8. 8 favorable, 8 total outcomes. And if I were to say these two were colored red, then this blue would say red, and the white would say red. And this would be red, 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 red. Now the total out times probability of heads and red would come up. It would be 1, 2, 3. It would be 3 in 8. And that's how you use a probability table and tree diagram to calculate overall probabilities with one independent event and 2 independent events. Now our assignment today, I feel like we use blue at the start, we use a little bit of red coloring, so we didn't use green, so let's pick it by chance, take a chance, we're going to do green. Your assignment today is page 416, numbers 3 to 6, and 9, only A and only B on number 9.